So here we've got a cross section or a little segment of the cell membrane. Okay, we know that the cell membrane is a phospholipid. These are these guys. They're little fat molecules. It's a phospholipid bilayer. That means it's two layers of fat, basically, little fat molecules that are facing one another. Okay? So the cell membrane is what we call semi-permeable, which means that it can let certain things go through, but it doesn't let other things go through. It's really good at keeping most of what's inside the cell inside and most of what's outside of the cell outside. We know that all throughout the membrane, we've got these actual proteins. Okay, and these proteins act as doorways. So I'm just going to actually put a little flap here and a flap here. Now, for the most part, okay, only certain molecules can use these doorways. First of all, they got to fit. If a molecule is this big, it's not going to fit through, right? So they've got to be a certain size. Now, using these doorways is nice and easy, but it costs energy. All right, so if something is on the outside and it has to be brought in through a doorway, the cell will open the door to bring it through, but it costs the cell energy. And here's the deal. Energy is expensive. We don't like, in the wintertime, do you leave your front door wide open?
No.
Why?
Because it's going to get your house all cold and then you're going to waste your...
It costs money to heat your house or your apartment. You're not going to leave the door wide open, right? That you're wasting energy there, and that costs money. Okay, well, the cell kind of works in the same way. So here's the deal. This costing energy to transport, okay, that's what we call active transport. The cell will do that when it has to. But for smaller little molecules, especially molecules like, I don't know, little molecules of water and little molecules of oxygen, which the cell desperately needs a lot of, right? Notice how these are really tiny. And the idea of diffusion, so first of all, let's remember, I'm going to actually add that right here. Diffusion is gases. Okay, so it's gases. Gases, atoms, molecules. Osmosis, on the other hand, osmosis is only water. Nothing else undergoes osmosis. But here's the deal. They're the exact same process. The only thing that's different about these two is what gets transported. So if we look at our cell membrane here, I'm going to use O2 or oxygen as an example because we all know that humans need oxygen to survive. We breathe in oxygen into our lungs. Well, we breathe in air and there's oxygen in it, right? But all that oxygen goes from inside your lungs into your blood vessels and gets carried all throughout your body because every cell in the body needs oxygen. Once it gets to right outside the cell, you've got a higher concentration of oxygen out here. You see that? There's more O2s on the outside of the cell than on the inside. Do you see any O2s on the inside? No. So the idea of diffusion is that molecules, in this case the gas, is going to want to go from an area or a place where there's a lot to an area or a place where there's not a lot. So if I have a full water bottle of water, if I've got a full water bottle here of water, okay, and it's full of water, and all of a sudden there's a hole right here, what is going to happen to the water? It's going to go spilling out because there's right at that moment in time, there's more in the cup than there is outside. It's going to want to go outside. Molecules naturally want to go to where there's not a lot of them. It's like when you're at a party of some sort or a get together and there's a room full of people And then you see a little corner of the room that doesn't have anybody there and there's a free seat and you're like, ooh, I want to go over there. Okay? Especially if you don't like people. All right? Or if a lot of people make you want to get over there. So you want to go from an area where there's a lot to an area where there's not a lot. Okay? So in this case, now all of these little molecules here, these fat molecules, yes, they're sort of touching, but there's spaces in between. And because these guys are so small, they can just zip right through to get inside. And it doesn't cost the cell any energy. So when diffusion occurs, it occurs because there's a higher concentration on the outside than on the inside. So things naturally want to go, free of charge. Osmosis, on the other hand, works the exact same way, but it's only water. Notice how there's more water molecules out here than there are inside. Well, the water is going to zip on through because it's a smaller molecule. And it's going to keep zipping through until the outside is even with the inside. Until there's the same concentration on both sides of the membrane. Does that make sense? So if we look at diffusion and osmosis, okay? So diffusion is the movement of gases from an area where there is lots to an area where there is little, in the hopes of evening it out. Does that make sense? So cells, especially for small little molecules like gas, especially oxygen, and carbon dioxide when we want to get rid of it, because at some point here, okay, after cellular respiration occurs, you are going to have more CO2 in here. You're going to have lots of CO2 here, but not a lot on the outside. Where's the CO2 going to want to go? It's going to want to go out because there's a higher concentration on the inside. It's then going to weasel its way through free of charge because it's going with the concentration gradient. Okay, there's a higher concentration on the inside, and concentration just means amount. There's a higher amount on the inside than there is on the outside. So it's going to go where there's not much. Case in point, a really good example, if I have a room, let's say this is my classroom right here, and the door is right here, okay? If somebody in this corner right here sprays a perfume bottle, like maybe once, of perfume in the corner, and there's somebody standing right at the door here, at that moment in time, as soon as it's sprayed, you won't smell it at the door here, right? But you come back 5 minutes later, nobody else is in the room, and then these particles move out to where there's less and less and less. They're diffusing all through the room. So that 5 minutes later, you actually get to the door and you're like, oh, I smell it. Smell perfume in here. Because there weren't a lot in all this space, and there was a very high concentration here, so they spread outwards. It's kind of like they're trying to colonize new unknown territory. So they're going where there's none. Okay? Osmosis is the exact same thing. It goes with the concentration gradient. It goes from where there is a lot to where there is little, but we're talking about water. Does that make sense?
Yes.